In the earlier session, we have tried to know about the concept of plate and plate tectonics and plate margins. We have seen that plates are in constant motion. During the plate movement, somewhere plate material is created, whereas somewhere it is destroyed. So, the question which immediately arises is, what are those areas where plate material created or destroyed? Why the plates are in motion? What is the driving force for the movement of the plates? Plate tectonic theory is the most comprehensive in nature. This theory is based on the study related to the ocean floor. The theory contributed to both understanding of features associated with the continental areas and ocean basin. Next question which strikes our mind is, what are the contribution of this theory in understanding the land features and ocean topography? Keeping these views in mind, the objectives set forth are: 1. To identify plate generation and plate destruction areas. 2. To bring out the contribution of this theory to mountain building activity and volcanism and seismicity. To identify the causes of plate movement. The two major features associated with plate boundaries are mid-oceanic ridges and trenches. Ocean ridges. The ocean ridges are associated with divergent plate boundaries. Along the mid-oceanic ridges, new lithospheric material or plate material is created. Mid-oceanic ridges are therefore plate generation areas. The plate margins are adjacent of mid-oceanic ridges, along which there will be divergence of plates. Due to the divergence of the plates, a gap is created, that is spreading center, along which the hot material rises and spreads on the ocean floor, that is sea floor spreading. The molten lava cools and solidifies to form new crust or plate material along the trailing ends of the divergent plates. As the oceanic plates diverges, rift is created and the hot material from the interior of the earth comes to the surface, solidifies and welded on the sides of the plate, forming new crust. The mid-oceanic ridges therefore are the plate generation areas, whereas volcanic activity and shallow focus earthquakes are common. Trenches. Trenches are formed along the convergent plate boundaries. Trenches are associated with the subduction zones, where one plate plunges below the other plate. Along the subduction zones, plate material is destroyed, where part of the plate or lithosphere descends into the mantle or ionosphere and melts. Trenches are mostly the subduction zones, which are mostly associated with deep focus earthquakes. The zone of deep focus earthquakes, that is the depth ranging between 300 to 700 kilometers, is called as Benioff zone. The Benioff zones are mostly located along the deep sea trenches. For example, Marianas Trench, the Philippines Trench. At the ocean trenches, two plates approach each other and slips under the margins of the other. It is thus seen that seafloor spreading occurs along the mid-oceanic ridges, which are called as sources, where new plate material is created and plate material is lost along the trenches. The area of plates or the crust destroyed almost equals to the area of new crust or plate material created. The process of mountain building is called as orogenesis. According to the theory of plate tectonics, the mountain building activity takes place along the convergent margins of the plate when two continental plates converge. The plate having the denser material is subducted under the less dense plate. The resultant lateral compression squeezes and folds the sediments on the either sides of the continental plate margins. Continent-continent plate collision occurs when two plates carrying continental crust collides. The best example of continental-continental plate convergence leading to the formation of fold mountains is related to the origin of Himalayas. In the geological past, there was extensive geosyncline, that is Tethys Sea, in the place of Himalayas. Eurasian plate is located to the north of Tethys Sea and Indian plate is located to the south. The sediments in the Tethys Sea began to contract and got folded in size due to the movement and collision of Eurasian and Indian plate. The European Alps result from the convergence of African and Eurasian plate. When continental and oceanic plate converge, the geosynclinal sediments derived from the continent commonly occur along the continental margins, produces mountain belt characterized by folding of sedimentary rocks. When there is a convergence of continental and oceanic plate, the oceanic plate being heavier is subducted below the continental plate. The sediments deposited along the continental plate margins are squeezed and folded due to the compressive force caused by the subduction of oceanic plate. The convergence of continental plate and oceanic plate resulted in the formation of Rocky and Andes mountains along the western margin of North and South America. The process of volcanism is well accounted by the theory of plate tectonics. There is a close relationship between plate boundaries and volcanic activities. Volcanoes occur both along the divergent as well as convergent plate boundaries. Most of the world's active volcanoes are found along the constructive or divergent plate boundaries. Volcanic activity is mostly associated with the destructive or convergent plate boundaries. When two convergent plates collide along the subduction zone, heavier or denser plate is subducted below the comparatively lighter plate. The subducted plate margin, after reaching a depth of about 100 kilometers or more in the upper mantle, is melted and thus magma is formed. This magma is forced to ascend by the enormous volume along with accumulated explosive gases. Thus, magma rises and appears as violent volcanic eruption, which is very common along the destructive or convergent plate boundary. A more or less continuous belt of volcanoes that encircles the whole of Pacific Ocean is called as ring of fire or girdle of fire. The volcanic activity believed to accompany continental rifting is exemplified by the large volcanic mountains such as Mount Kilimanjaro. The distribution of volcanoes and seismic zones reveals that they are more or less similar. The seismic zones are mostly confined to plate boundaries. Seismicity is limited to mid-oceanic ridges, trenches, major fracture zones and belts of young fold mountains. All these features indicate plate boundaries. Mid-oceanic ridges which are divergent plate boundaries, are associated with shallow focus earthquakes. Intermediate or deep focus earthquakes, which have focus deeper than 300 kilometers, are mostly found within the oceanic trench zones. This is the area where plate descends starting from 300 up to a depth of 700 kilometers. The inclination of this zone is towards the continental mass, and the angle of inclination varies between 30 to 80 degrees. Such inclined deep focus seismic zone is called as Benioff zones, which are mostly in the form of trenches. Deep focus seismic zones encircles the entire Pacific coast, which is called as Pacific Ring of Fire. The mid-oceanic ridges are commonly offset by large faults, that is transform faults. It is here that the plates slide past one another. It is the zone of conservative plate boundary, which is also the site of shallow focus earthquakes. The best example known this type of fault is California's San Andreas Fault. One of the major causes identified for the movement of plates is given by Sir Arthur Holmes, which is related to thermal convection currents. Thermal convection currents are generated in the mantle, is believed to be the main driving force for the plate motion. Thermal convection currents are generated into the mantle due to the presence of radioactive material in the mantle, which is unequally distributed. The unequal distribution of radioactive material produces differences in heat generated due to the decay of the radioactive material, thus generating circular convection currents. The rising or the upward moving convection current leads to the opening of the Earth's crust. The rising limb of the thermal convective currents spreads the hot material from the interior of the Earth. The movement of the plate along the opening of the Earth crust will be divergent. The hot material from the interior of the Earth is attached to the trailing ends of the plates, which is dragged horizontally in opposite direction, due to which there will be divergent movement of the plates along the rising thermal convection current, which will be mostly along the mid-oceanic ridges. New plate material is generated along the mid-oceanic ridges. Along the sink or subduction zones, that is trenches, where the descending thermal convection currents meets, plates are dragged towards each other, and thus there will be collision of plates. Scientific community have accorded acceptance to the mechanism of thermal convective currents. The rising convection currents transports hot and liquid matter upwards, which after reaching the crust, that is plates, splits and diverge in opposite direction in the form of horizontal flow. Tuzo-Wilson gave mantle-proof model which explains the concept of hot spots or the mantle plumes, which also throw light on the plate motion. Hot spots are the sites of rising of or upwelling of magma. Hot spots occur mostly along the mid-oceanic ridge. Hot spots are the near surface manifestations of convection in the lower mantle, which provides motive force for the plates. According to some scientists, potential gravitational energy is the driving force for the movement of the plates. There are three mechanisms for the plate movement. 1. Push mechanism, 2. Pull mechanism, and 3. Drag mechanism. In the push mechanism, there will be rise of hotter mantle material below the ocean ridges that produces low density bulge, which exerts gravitational pressure on the plates on the either sides of the ridge, due to which there will be divergence of the plates along the mid-oceanic ridges, that is ridge push. This subduction aided by gravity pull. For example, plates like Pacific and Cocos, which have about 40% of their margins represented by the subduction zones, have velocity of 5 centimeters per year. Plate like the North American, which has a smaller proportion of subducting margins, move very slowly at the rate of 1 to 3 centimeters per year. Hence, it can be said that the major driving force is slap pull. In the process of drag mechanism, lateral convective flow within the ionosphere pulls the plate apart. There is a differential movement of the plates. The rate at which the plate moves along the divergent and convergent plate boundaries vary considerably. The Arctic ridge has the slowest rate of movement, which is at the rate of less than 2.5 centimeters per year. The fastest rate of the plate movement, that is more than 15 centimeter per year, is observed near East Pacific Rise in South Pacific Ocean, about 3,400 kilometers west of Chile. The motion of small plate is controlled by the comprehensive force of major plates. The Indian plate includes peninsular India and Australian continental landmass. In the east, it extends from Rukin-Yoma mountains of Myanmar towards the island arc along Java Trench. The eastern margin of this plate is the oceanic portion in the form of spreading site lying east of Australia in the form of oceanic ridge in southwest Pacific Ocean. The western margin follows Kirthar mountains of Pakistan. It further extends and joins the spreading site from the Red Sea Rift. Southwestwards along the Chagos archipelago, the southern boundary between India and Antarctic plate is also marked by oceanic ridge, that is divergent plate boundary, running roughly in east-west direction and merging into spreading site a little south of New Zealand. The subduction zone along Himalayas forms the northern plate boundary. In the geological past, India was in the form of a large island situated off the Australian coast. The Tethys Sea separated from the Asian continent till about 225 million years ago. India is supposed to have started her northward journey about 200 million years ago. India collided with Asia about 40 to 50 million years ago, causing rapid uplift of Himalayas. About 140 million years before the present, the subcontinent was located as far as 50 degrees south latitude. The major plates which are separated from the Tethys Sea and the Tibetan block was closer to the Asiatic landmass. During the movement of the Indian plate towards the Eurasian plate, a major event that occurred was the outpouring of lava and formation of Deccan traps. This started somewhere around 60 million years ago and continued for a long period of time. The Indian subcontinent was closer to the equator. From 40 million years ago and thereafter, the event of formation of the Himalayas took place. Scientists believe that the process is still continuing and the height of Himalayas is rising even today. During the past 50 years, the theory of plate tectonics revolutionized earth sciences like perhaps no other before. The theory of plate tectonics forms the basis of our current understanding of the dynamic nature of the earth. Plate tectonics theory explains the evolution of first order relief on the earth's surface, such as continents and oceans. This theory explains orogenesis of fold mountains. Plate tectonics theory accounts for the seismicity and volcanism. Plate tectonic theory not only explains about the relief on the continents, but also explains about various features of the ocean, such as evolution of mid-oceanic ridges and formation of trenches or subduction zones. The theory also explains about the evolution of volcanic islands and island arcs. Even though the theory of plate tectonics is the most comprehensive theory with scientific outlook, there are few criticisms leveled against this theory by the geologists and geophysicists, which are as under. Plate tectonics theory is unable to explain as to why subduction is mostly limited to the Pacific Ocean, while spreading centers are found in all the oceans. The length of spreading center is much greater than the subduction zones. That is, the rate of creation of new crust appears to be much greater than the rate of plate destruction. Mid-oceanic ridges, that is sources, are the greater length than the trenches and sinks, which implies that crustal generation exceeds crustal destruction. Therefore, do not support the constant surface area assumption. Plate tectonic theory do not account for the intraplate earthquakes and volcanism. Scientists are not certain as to when plate motion and interaction first begin to play a significant role in the global tectonics. The plate tectonic theory provides less knowledge about the nature of newly developed plate boundaries. The theory of plate tectonics does not fully provide a satisfactory explanation related to all mountain building activity. There are several mountain ranges such as Eastern Highlands of Australia, Drakensberg Mountain of South Africa and Sierra del Mar cannot be related to plate tectonics. Plate tectonic theory is the post-drift theory, which is the advanced and the scientific version of the continental drift theory. Plate tectonic theory was developed in the 1960s and the basis of the theory lies in the concept of seafloor spreading. In plate tectonics theory, the term plate is used instead of continents. The plate material is made up of both continental and oceanic material. The lithosphere or the Earth's crust is compartmentalized into 7 major plates and 20 minor plates. These plates are sliding past over the asthenosphere, which is viscous in nature. An insight into the analysis of plate margins is basic in the understanding of the theory of plate tectonics, because all the tectonic activities are associated with plate boundaries. There are 3 types of plate boundaries, that is convergent, divergent, conservative plate boundaries. Divergent plate boundaries are associated with mid-oceanic ridges. Along the convergent or collisional plate boundaries, 2 plates with differences in density meet and the lighter plate plunges below the denser plate. The zone along which one plate plunges or sinks below the another is called as subduction zone, which is generally associated with ocean trenches. The convergent boundaries are of three types: formation of the fold mountains, volcanic islands, trenches, etc. are associated with convergent plate boundaries. Plate material is destroyed along the convergent plate boundaries. Along the conservative plate, material is neither created or destroyed. The movement of the plate is parallel or lateral in conservative plate boundaries. Plate tectonics have contributed to the understanding of the evolution of land tectonic features like folding, wrapping, faulting, rifting of the continental crust. Besides, plate tectonic theory also contributed to the understanding of ocean bottom relief features such as mid-oceanic ridges, ocean trenches, volcanic islands and island arcs. Today, it is the most scientifically approved theory to understand the dynamic nature of the Earth's surface.